The numbers in the two triangles add up to the number in the square. So they've given us an example here. We have 10, 15, and then in the square we have 25, because 10 plus 15 is 25. But now, using the same rule, write in the missing numbers. So we have 25 and something, and then in the square we have 120. Now, if you're not sure what to do here, what you can do is look back to the example. So imagine this triangle here was missing. How would we be able to find it? We'd have 10 plus something is 25, and we'd be able to work out this missing triangle by working out 25 minus 10 to make 15. So we need to work out 120 minus 25. What we really have here is a missing number addition, so we use subtraction to find our missing number. We can work this out using column method, and that gives us 95 as our missing number. So now we have 55, 75, and this time it's the square that's missing. Well, if we look back to our rule, the numbers in the two triangles add up to the number in the square. So to get our square, we need to add what's in the two triangles. And we can see from the example, we have 25 in the square because 10 plus 15 is 25. So we can add using column addition, and that gives us 130 as our missing number. Draw the reflection of all the shaded shapes in the mirror line. So this shape here is 1 to the left, so we can shade 1 to the right. This shape here is 3 to the right, so we can shade 3 to the left. And then this shape here is 2 to the left, so we can shade 2 to the right. So that way we have the same reflected on both sides of the mirror line. Circle the number that is closest to 300. So 338 is 38 more than 300. 3030 is not close to 300. 288 is 12 less, because if we add 12 to 288, we'll get 300, because 88 and 12 make a number bond to 100. So that means the 2 in our hundreds becomes a 3. Or we could work this out by working out that 300 minus 288 is 12. 313 is 13 more, and 130 is not close. So that means the closest number is 288, because that only has a difference of 12, so has the smallest difference. The number 20 goes in 2 of the squares of this multiplication grid. Tick the 2 squares where 20 goes. So we need to think what times what is 20. Well, 5 times 4 is 20, so we can tick this square because that shows 5 if we go to the left, times 4 if we go up, and 5 times 4 is 20. And we can also tick this square, because if 5 times 4 is 20, then 4 times 5 is 20 as well. Here are 3 nets of a cube. On each net, draw 1 more dot so that each cube will have dots on opposite faces. So if we imagine the dot that they've given us is on the bottom of the cube, we want to dot the face which will be the top of the cube, so that we have dots on opposite faces. So if this dot is the base of the cube, these 4 sides, these 4 faces will fold up, and then this face here will fold all the way over the top. So we need our dot on this face here. Now here, if we imagine this face with the dot is the base or bottom of the cube, this face will fold up, these faces will fold around, When this face folds round, this face on the end will fold all the way round and cover this edge, and this face here, once this face has folded up, this face will fold over the top. So we need our dot on this face here. Now, if this dot is the base of the cube, this side will fold up, this side will fold around and cover this edge, and when that happens, this face here will be able to fold all the way around and cover this edge, which means that this face will fold all the way around and cover this edge here. So we need our dot on this face because that will fold over the top. This diagram shows how 9 people travel to work and how far away they live. How many people live more than 4 kilometers from work? So we can see that we have work in the middle, and this circle here shows 4 kilometers. So if they're inside the circle, that will be less than 4 kilometers, and outside will be more. So we can see that we have this person here, this person here, this person here, and this person who all live more than 4 kilometers away. So that's 4 people altogether. Now, how far from work does person G live? Well, we can see that person G is here. Now this circle shows 4 kilometers and this circle shows 6. And person G is right in the middle of those circles, so right in the middle of 4 and 6. So that's 5 kilometers. Now write the letter of the person who lives 2 kilometers from work and cycles. So on the key, we can see that a dot shows a person that cycles, and this is our circle for 2 kilometers, and the only circle we have on this line, or this circle showing 2 kilometers, is person D. So that's our answer. Megan and Chen are washing cars. Megan gets £39 and Chen gets £55. They share what they get equally between them. How much does each of them get? So to solve this, we need to find out the total of what they get, and then because they share equally and there are 2 children, we can divide by 2. So first, £55 plus £39 is £94, and if we divide that by 2, because 2 children share equally, we get 47. So they each get £47. They make £94 in total, but because they share equally, they each get £47. The table shows the cost of a new football kit. Altogether, how much does the complete football kit cost? So we need to add the cost of the shirt, the shorts, and the socks. So we need to add these 3 numbers here. And the easiest way to add 3 numbers together is first to add 2 of the numbers, so we can work out £8.75 plus £5.95, and that gives us £14.70. And then we could add the third item, so add £4.15 to that. And that gives us the total cost of £18.85. Here are some sentences about an amount of money. Mark each sentence with a tick if it is correct, put a cross if it is not correct. First, £1 3 pence can be made with exactly 1 coin. That's not correct because there's not a £1 3 pence coin. Now, £1 3 pence can be made with exactly 2 coins. That's not correct either, because though we have a £1 coin, we do not have a 3 pence coin. Now, £1 3 pence can be made with exactly 3 coins. That's true, because we have a £1 coin, a 2 pence coin, and a 1 pence coin. And if we put these 3 coins together, we get £1 3 pence. And finally, £1 3 pence can be made with exactly 4 coins. That's true as well, because we can have a 50p coin, another 50p coin, so that's £1, a 2p coin, and a 1p coin, so that's 3p. Or we could have a £1 coin and then 3 1p coins, because 3 1p coins will total 3p, so that's 4 coins to give us £1, 3p. Here are 4 designs made from 2 sizes of circles. Write the letters of all the designs that have a line of symmetry. So a line of symmetry is a line down the middle of the shape where you have the same reflected on both sides. So shape A has a line of symmetry here because we could fold one side over so that it completely covered the other side with nothing overlapping. So this half of the circle and this half of the circle would cover each other up if we folded the shape over along the line of symmetry. And shape B has a line of symmetry here. Again, we have the same reflected on both sides. We could fold one side over so that it completely covered the other side. Shape C and D do not have a line of symmetry. With shape D, if we tried to draw a vertical line of symmetry, then we wouldn't have the same reflected on both sides because we only have one circle on this side but 2 on this side. And if we tried a horizontal line of symmetry, that wouldn't work because we have a circle down here but not up here. So the only designs with a line of symmetry are A and B. Write in the missing numbers. So we need to round these numbers to the nearest whole number. To round decimals to the nearest whole number, we need to look at the digit before the decimal point, so at our ones digit. Then, as always with rounding, we look at the digit to the right, so look at our tenths digit. And remember, if it's 4 or less, like it is here, we round down. So that means the 5 stays the same, so 5.05 to the nearest whole number is 5. Now we have 5.55. So again, we circle the digit before the decimal point and look at the digit after it. We have a 5, and if we have 5 or more, like we do here, we round up. So that means the digit that we've circled increases by 1. So this 5 will become a 6. And what that tells us is that 5.55 is closer to 6 than it is to 5. Now 4.45. We circle our ones and look at our tenths. It's a 4, and if it's 4 or less, we round down. So that means the 4 that we've circled stays the same. And finally, 4.54. We circle our ones, look at the digit to the right, and because it's a 5, we need to round up. So this 4 will become a 5. Complete these calculations. First, 15 times 100. That's 1,500, because if we have a whole number, we can multiply by 100 just by putting 2 zeros on the end. If we have 2 end zeros in the question, there will be 2 end zeros in the answer. Now, something times 10 equals 1,500. That's 150, because we have 2 end zeros here, so we need 2 end zeros in the question. So 1 here and 1 here, giving us 2 end zeros in our answer. 15 times 1 is 15, and then we have a total of 2 end zeros. Something divided by 100 equals 150. So here our missing number is 15,000, because if we cancel the 2 end zeros, that leaves us with 150 divided by 1 as our question. Also remember, division problems can be read backwards as multiplication problems, and 150 times 100 is 15,000 because we can multiply by 100 by putting 2 extra zeros on the end. And finally, 150 divided by 10 is 15, because we can cancel and end 0, and 15 divided by 1 is 15. Alfie places 3 cubes on a coordinate grid. The base of his shape is a rectangle. Complete this sentence. The 4 vertices of the rectangle are 2, 3, 5, 3, 5, 4, and what else? So the vertices of a shape are the corners. So the 4th corner will be here. That will be in line with the 2, so that's our x-coordinate, because we can see that the x-coordinate here is 2, and this point will be in line, and it will have a y-coordinate of 4, so the same as the y-coordinate here. So that means the coordinates will be 2, 4. Tick each shape that is exactly 1/4 shaded. So 1/4 shaded means 1 shaded part out of every 4 parts. But these shapes that we have aren't split into 4 pieces. They're each split into 12 pieces. We have 12 little squares inside each rectangle. So what we need to do is find a fraction equivalent to 1/4, which has a denominator of 12. Now to find equivalent fractions, we can use multiplication. 4 times 3 is 12, so if we do the same to the numerator, 1 times 3 is 3. So because 1/4 is the same as 3/12, we need to tick the shapes where 3 of the 12 pieces are shaded. So here we have 3 out of 12 pieces shaded. Here we have more than 3, and here we have more than 3 as well. But for this shape, again, we have 3 shaded pieces and 12 pieces altogether, and that's equivalent or the same as 1/4, so we can tick this shape as well. 4 children are in a race. Chen is 2 meters ahead of Alfie. Nina is 5 meters behind Megan. Alfie is 3 meters behind Megan. Write the names of the runners in order, starting with the child who is furthest ahead. So what we can do to solve this question is to draw a diagram to show what's happening. So Chen is 2 meters ahead of Alfie. And then in our next statement, we're told that Nina is 5 meters behind Megan. But we don't know where to write that on our diagram because we only know about Chen and Alfie. So we don't know if Nina and Megan are further ahead up here or further behind. But the next statement tells us that Alfie is 3 meters behind Megan. And because that statement mentions a child who we already know about, we can write that on our diagram next. So we have Alfie, and he's 3 meters behind Megan. So Megan is 3 meters in front of Alfie. So now we can come back to our second statement. Nina is 5 meters behind Megan. So Nina is 5 meters behind Megan, which means that Megan must be the furthest ahead. Then we have Chen, then Alfie, and then furthest behind is Nina. Alfie buys 2 books, each at the same price. He pays with a £10 note and gets £2.30 change. What is the cost of 1 book? So we know that he buys 2 books, and first we can work out how much he spends and then divide by 2 to find the cost of 1 book. So to find how much he spends, we can subtract the change from how much he pays, and £10 minus £2.30 is £7.70. So that's how much 2 books cost. But we want to know the cost of 1 book, so we need to divide by 2. We can use short division, and that gives us £3.85. So that's the cost of 1 book. This graph shows the distance Alfie and Chen walked in an afternoon. they started at 1:45 p.m. and had 2 breaks. How many kilometres did they walk between the first and second breaks? So we can see on the line graph where they had their breaks, because if they're having a break, then they're not covering any more distance, so the line will be flat or horizontal. So they had their first break here when they'd walked 6 kilometres, and then they had their second break here when they'd covered 10 kilometres altogether. Now we want to know how many kilometres they walked between, so the space between 6 and 10. So we need to find the difference, and 10 minus 6 is 4, so they walked 4 kilometres, because on their first break they were on 6, and then they walked another 4 kilometres, so that they were on 10 kilometres by their second break. Now, at what time did Alfie and Chen start their second break? So the start of the second break will be the start of the second horizontal line, so that's here. Now we have time on the bottom, so if we draw a straight line down, we can see that it's after 4 o'clock, and we need to read the scale really carefully here. To get from 1 hour to the next, we have 1, 2, 3, 4 lines, and because that's the first line after 4, we have 1/4 past 4, or 1/4 past 4, which we write as 4:15, because remember, there's 60 minutes in an hour, and 1/4 of 60 is 15. So they started their second break at 4:15 p.m. Here is a spinner. Write a whole number in each section of the spinner so that it is certain you will get a number less than 4, and it is impossible you will get an even number. So certain means that it's definitely going to happen, so all of the numbers on the spinner will need to be less than 4, and impossible means that it's definitely not going to happen, so we can't write any even numbers on our spinner. Remember, even numbers end in 2, 4, 6, 8 or 0. Now it doesn't say that we can't use the same number in different sections. So here we could write 1 in every section of the spinner. That means it's certain you will get a number less than 4 because 1 is less than 4, and it is impossible you will get an even number because 1 is an odd, not an even number. Or we could write 3 in every section of the spinner, or a combination of 1s and 3s. Calculate 816 divided by 24. So we need to work out our 24 times table. 24 is 1 times 24. If we add another 24, we get 48, so that's 2 times. Another 24 gives us 72 for 3 times. We have 96 for 4 times, and if we add another 24, that gives us 120 for 5 times. Now when we get to 5 times, we can look back at the question. Taking the first 2 digits together, we have 81. So we need to find a number as close to 81 as possible, but not more than 81. So here, that's 72. So we can write that below. And because 72 is 3 times, we can write 3 in our answer line. Now we subtract and bring down. 81 minus 72 is 9, and we can bring down the 6, so we have 96. We can see that that's exactly 4 times, so we have 4 as the ones digit of our answer, 34. Chen and Megan each have a parcel. Chen's parcel weighs 1.5 kilograms. Megan's parcel weighs 1.2 kilograms. How many more grams does Chen's parcel weigh than Megan's parcel? So we know that 1 kilogram is 1,000 grams. So that means that half a kilogram is 500 grams, because half of 1,000 divided by 2 is 500. So Chen's parcel is 1.5 kilograms, so that means it's 1,500 grams. So putting these two together gives us 1,500. Megan's parcel weighs 1.2 kilograms, so we need to work out how many grams there are in 1.2 kilograms. Now when you're given a weight in kilograms that's a decimal, to change it into grams, what you can do is write the decimal but with zeros on the end so that it's got 3 decimal places, 3 digits after the decimal point. And then you can just take out the decimal point, so that's 1,200 grams. And that makes sense because 1.2 is just a little bit more than 1, and 1,200 is a bit more than 1,000. So the question asks us how many more, which means that we're finding the difference. We're comparing two values, so we need to subtract. And 1,500 minus 1,200 is 300. So our answer is 300 grams. 20% of Megan's number is 64. What is 50% of Megan's number? So 100%, this top bar, represents Megan's number, and 10% will make 100% because 10 times 10 is 100. Now Megan has 20%, so that's 2 10%. So 20% is 64, which means that we can find 10% by finding half of 64, or dividing 64 by 2, and that gives us 32. So if 20% is 64, that means 10% is 32, but we want to find 50%, and that's the same as 5 10%. So to work out 50%, if we know that 10% is 32, we can multiply 32 by 5, because 10% times 5 is 50%, and 32 times 5 is 160, so that must be 50% of Megan's number. There is another way of working this out. 20% is 20 hundredths, but we can simplify that to 2 tenths. So we know that 2 tenths, or 20%, of Megan's number is 64. So we can write what we know as a missing number problem. Now usually, to find a fraction of a number, we divide denominator times top. But here, because it's a missing number problem, we need to divide by the numerator, and 64 divided by 2 is 32, and then we can multiply that by the denominator, and 32 times 10 is 320. So Megan's number is 320, but we want to know 50% of Megan's number, so 50% of 320. 50% is the same as 1/2, and 1/2 of 320 is 160, because 320 divided by 2 is 160. Write these in order of size, starting with the smallest. So we can see that we have a mixture of fractions and decimals. So to compare these numbers, we can convert our fractions into decimals. Now 3/5 is the same as 6/10, and that means that as a decimal, we can write 3/5 as 0.6, because remember, the first digit after the decimal point always tells us how many tenths we have. But with 2/3, we can't find an equivalent number of tenths because 10 is not in the 3 times table. And 100 is not in the 3 times table either, and nor is 1,000. So how can we change 2/3 into a decimal? Well, remember, a fraction is really a division, so 2/3 is the same as 2 divided by 3. So that's 0 remainder 2, but we can extend our dividend with a 0.0 and write the remainder 2 in front of that, of course after copying up the decimal point. Now 20 divided by 3 is 6 remainder 2, so we need to extend with another 0 to write our remainder in front of. But we still have 20 divided by 3, so that's 6 remainder 2 again. And then we can see that this would keep on going forever. So 2/3 is the same as 0.666, and these 6's would go on forever. It's what we call a recurring decimal. So 1/3 is the same as 0.3333 and so on, and 2/3 the same as 0.6666 and so on. It's what we call a recurring decimal, so we can draw a dot above the digit that's repeated. We could write this as 0.6 and write the dot above the first 6. But we can think of 2/3 as being around 0.66, so really just a bit more than that. But that will help us to compare these decimals. Remember, we can write zeros on the end of decimals, and now we can compare them. So 0.50 is smallest, so we can write 0.5 in this box. Then we have 0.60, so we started there with 3/5. Then 0.65, and our largest number is 2/3, because that's the same as 0.6 recurring. Alfie has some rectangles, so we can see that the shorter sides are 3 centimeters and the longer sides 8 centimeters. He makes this shape using 3 of the rectangles. What is the perimeter of Alfie's shape? So we need to remember that the perimeter is the distance around the outside of the shape. So we can write the lengths of the sides we know. We know that the longer sides of the rectangles are 8 centimeters and the shorter sides 3 centimeters. So we can write these values on our shape. But we have these two lengths here, which we don't know, but which we can work out. Notice here, we have the shorter end of a rectangle, so that's 3 centimeters, and we have the longer length here, which is 8 centimeters. So now, something plus 3 has the same length as 8. So we know that these lengths must be 5, because 5 plus 3 is 8, and we know and we can see that the lengths are the same. So we have 4/8, that's 32, we have 4 3s, so that's 12, and we have 2 5s, so that's 10. So if we add up all the lengths that we've written, so the lengths around the outside of the shape, we get 54 centimeters, so that's our perimeter. Notice when we're finding the perimeter, we don't write or we don't add these lengths here, because this length here is not on the outside of a shape, and the perimeter is the distance around the outside. A cake costs 15p more than a biscuit. Megan bought a cake and 2 biscuits for 90p. How much do a cake and a biscuit cost? So for this question, we can either use trial and improvement, or we can draw a bar model. We know that Megan bought a cake and 2 biscuits, and that cost 90p altogether. Now a cake is 15p more than a biscuit, so underneath our bar for cake, we can have another bar and then 15p. And if we copy down our bars for biscuits, we can see that we have these 3 bars plus 15p has to total 90p. So if we subtract 15 from 90, that tells us that these 3 bars together have to total 75p. And if 3 bars are 75 pence, we can find the value of each bar by dividing 75 pence by 3. That gives us 25 pence. So we know that each cake costs 40 pence, because 25 plus 15 is 40. And we know that each biscuit costs 25 pence. Chen and Megan each have a set of numbered counters. So we can see that Chen has 4 counters labelled 1 to 4 and Megan 5 counters labelled 1 to 5. They each take one of their own counters without looking. Chen says, "I am more likely than Megan to get a 4. Is Chen correct? Explain how you know." Well, here Chen is correct. That's because he has a 1 in 4 chance of getting a 4. So we can write a 1 in 4 chance as 1 over 4 or 1/4. He will get a 4 1/4 of the time. But Megan has a 1 in 5 chance of getting a 4. We can write that as 1/5 because she'll get a 4 1/5 of the time, 1 in every 5 times on average. So the reason why Chen is correct is because 1/4, so his chance, is larger than 1/5, so Megan's chance.